Science in pajamas. Pajamas. Hi guys, today we're going to be talking about population density and population size. So as you remember, hopefully from previous videos, population is the... Hi! Hi, good boy. Yes. Okay. Come here. There you go. So Alexa, lay in my lap. So population... Oh my goodness, I just can't take how cute he is. Look at that. Look at how cute he is. Hi, Ripley. Hi, good boy. Sorry. I apologize for that. So population is a group of individuals that live in the same area, such as a pride of lions would be a population, or a herd of zebra, or a wolf pack. All those would be a population. Now, when we talk about populations, there are three main characteristics that we want to look at when it comes to populations. The first is the geographic distribution, which is looking at where are they actually located, what is their area or their territory. The next is the density, and then so how many individuals are there in that area. And then the last is population growth rate. And that's looking at how the size of the population might change. Now, we're going to be talking primarily about density and population size or growth rate, just because those have a couple mathematical equations that you can use to help figure out those trends. But sorry, I'm just so distracted by how cute Ripley is. He's such a cute little boy. Sorry, I get easily distracted by him, I know. So let's start off with density, shall we? As we said, population density is the number of individuals that live in that given area. It's very similar to like the concentration of a substance. When we were talking about concentrations and the density of a subject back in the biochem videos, we were saying how it's the amount of molecules for that substance in one volume of medium. Well, it's kind of the same idea. It's the number of individuals in that given area. So, try to maneuver around Ripley. It's okay. I'm just going to shift you over a little bit so I can shift my legs over. So, we can actually figure this out mathematically. Let's say we have shift you a little bit more, little man. I'm sorry. Yeah. There you go, Ripples. Alright. Now you can be comfortable and I can still write on the board. Yes, hi. Alright, so let's say that there's a population of... Oh, sure. Now you get a silly boy. There's a population of 10 deer, and they live in an area that is 15 kilometers squared. Because just like in math class, how you find the area is like, length times width, so it ends up being a squared number. So we have 10 deer that live in an area of 15 kilometers squared. Well, how we do this is, for population density, it's the number of individuals per area, which is in a unit squared. So we have 10 deer over 15 kilometers squared. So when we go through and we figure that out, the population density for the deer would be 1.5 deer per kilometer squared. Alright, wait a minute. No. Oh, goodness. I divided that the wrong way in my head. Alright, sorry. Alright, sorry about that. I divide 15 by 10. That was my bad. Oh, Komar has issues sometimes, doesn't she? Yeah. Alright, sorry about that. So it would actually be 0.67 deer per kilometer squared. Alright, let's do a simpler one. It is first thing in the morning, so I apologize. Yeah. Let's do another one. We're still looking at deer. Let's say we have 20 deer in an area that is actually 15 kilometers square is a really big area for 10 deer. I probably meant to put 1.5. Anyway, I'm getting off that topic about that problem. So 20 deer in an area that is 4 kilometers squared. So we solve that. The population density is 20 deer per 4 kilometers squared equals 5 deer per kilometer squared. There we go. Now we can also kind of use graphics to depict this. One of the ones I use in my class is similar to the following. One, two, three. Roughly the same area. We're going to pretend like they're exactly the same. And we have three people there. Some more people here, and 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 here. Alright. So here we have 3 areas that are the same. Which of these circles have a higher population density? Remember, the definition of population density is the number of individuals per area. Well, all the areas are the same. So therefore, we have to look at the number of individuals. This one clearly has a lot more individuals in the same area. So this one has the highest population density because it's got the most people in the same area. This one has the lowest population density. It's got the least amount of people per that exact same area. All right, so now let's move on to growth rate. So growth rate looks at how a population will change in size. So we have, this is our population. And there are 4 factors that will affect the size of the population. The first one being the number of individuals born into the population. So the births. The next one The next one would be the number of deaths. So how many individuals die in that population? Because if they're dead, then they're no longer part of the population. All right. Now those two make sense because we talk about, let's say if we're talking about deer, all right, so there's our cute little deer. How many fawns are born each year? That would be the number of births. Now, the number of births means that we have new deer being born, so that means that we are going to increase the population. It's going to increase the number of individuals. That's why we have the arrow pointing in. But the number of individuals that starve or are hunted by predators or even by people, that's going to result in deaths. And deaths take individuals out of the population because they're no longer there to interact, to breed, to eat. So they're no longer part of the population, which is why death has the arrows pointing out. So births and deaths makes sense. But there's also two more that we don't always realize go on. Next one would be immigration. Sometimes there are lone deer who might join up with a herd and become part of that herd. So they weren't initially part of it. Maybe for whatever reason they got separated from their herd and they joined this one and the herd welcomes them. Well, now we have a new individual joining the population. So that, again, arrow pointing in. Flip of that, the opposite of that would be emigration. And what emigration is, the number of individuals who choose to leave the population, or for whatever reason they leave the population without being killed. So that can mean either they got lost from their herd and they can't, find them to rejoin them. It could be in the case of lions, if a young male, a juvenile male lion grows up and gets kicked out by the father or by the, I don't want to say alpha, by the male in charge of the lion pride. There's usually one male in charge and he has got all the rights to the females. He doesn't want to share that, so a lot of times young males will be kicked out of the pride before they can challenge the lead male. So since they're being kicked out, they are emigrating out of the population. Now we can use these to figure out the population size. How we do that would be R, which is the population size, births plus immigration minus deaths plus emigration. So this would let us know in full how a population changes from one year to the next. So let's say that we, in the first year, we're recording the number of births, deaths, immigration, and emigration within a deer herd. Maybe there were 10 born plus 2 that entered the herd. There were 8 that died plus 1 that left the herd. So that means that there was a change in the population of 10 plus 2 is 12 minus 9 have a net gain of 3 individuals for that year. So that means if the original population was 36, it is now, with a net gain of 3, the population has increased to 39 individuals. Because we had 10 born and 2 that entered via immigration, but 8 died and 1 that left on its own. So the net change is going to be a positive 3. So that means that from the previous population size to considering this, everything that's occurred, we have a net gain of 3. So 36 plus 3 equals 39. All right. Let's say the next year is pretty bad. We have 6 born plus 1 that immigrated in minus 11 that died. Maybe there wasn't as much food that year. Plus 2 that left. Alright, so 6 plus 1 is 7 minus 13. So that means we have a net change of negative 6 deer. Now what it means to be negative, it means that you actually lost more of the population than you added to it. So in this case, it'd be 39 plus negative 6, or 39 minus 6, and that means that the population size in this year has become 33. All right? Not too bad. Not too horrible, I hope. But that's pretty much what we're talking about in terms of the growth rate and the density. So I hope this was informative and helpful for you guys. I hope that it helped to explain some of these things. And until next time, you guys just stay awesome, stay amazing, and I will see you later. All right. Be safe. Bye-bye.